Okay, so what is the Q value for this nuclear reaction? So we've got beryllium-9 plus an alpha particle going to carbon-12 plus a neutron. So the Q value here is just the sum of the mass of the reactants. I'm going to put the sum of the mass for reactants minus the sum of the mass for the products times C squared. So this is our rest mass energy. Okay, so then for this to not give you a non-zero result, you're going to need slightly more decimal places. So for beryllium-9, we've got our mass is 9.012182 grams per mole. For an alpha particle, which is a helium nucleus with an electron, it's 4.001506 grams per mole. For carbon-12, this is defined as 12.000. And for a neutron, we have our mass is 1.008665. Okay. So then now our Q value is just the sum of our reactants 4.001506 minus the sum of our products okay times C squared. So this value in here comes out to be 0.005023 grams per mole, and then we're going to multiply by 2.99792,458 times 10 to the 8 meters per second squared. So to get into joules, this guy's going to need to be in kilograms. So I'm going to multiply by a kilogram per 1,000 grams. And to get rid of the mole, we're going to divide by Avogadro's constant. 409 times 10 to the 23, 1 over mole. So that'll get rid of the grams, that'll get rid of the moles, and it'll put the whole thing in joules. And so it comes out to be 7.496 times 10 to the minus 13 joules, which we can convert into EV by multiplying by 1 EV per 1.602177 times 10 to the 19 joules, which comes out to be 4.7 times 10 to the 6 EV, or 4.7 MeV. So the closest answer given here, so the answers given vary from 5 to about 10. The closest answer is C at 4.2 EV. I will say that the calculated answer you get will vary quite a bit depending on the amount of decimal places you use on your masses. So I assume 4.2 EVs are 4.2, should say MeV, is what you would get if they gave you a table of masses, which is what I would assume happened. All right, so let's look through the solution here. If the total mass of the products is less than the initial, then the energy has been released. In this case, it has a positive Q value. Okay. So comparing the masses on both sides, so that's wrong because they've dropped that the alpha particle has a mass. It's basically a helium nucleus, so it should be about 4. And so if you use 0 decimal places, your answer is going to be 0. Because 9 plus 4 is 13 and 12 plus 1 is 13, so it looks like you have a mass difference of 0. And so they just chose C because incorrectly getting the helium mass gives you 4. So it is C, I believe. So alpha particle is helium nucleus, therefore has mass of roughly 4. C is the answer, but not for this reason. Okay, so that's incorrect, I'm going to say.